All right, so number 7. Number 7 says the diagram below shows the index minerals of Mohs hardness scale compared to the hardness of some common objects. All right. So it says which statement is best supported by the diagram. So remember the rule with hardness. A mineral can scratch another mineral if the hardness is equal or higher than the other object. So if you have an object of a hardness of 6, it can scratch any object that has a hardness of 6 or less. So let's see. A fingernail will scratch calcite, but not gypsum. If I take a look, a fingernail will scratch calcite. That is incorrect. Calcite is higher than the fingernail. So it will not scratch calcite. So that is false. That already makes it false. It says calcite will be scratched by a copper penny. That is true because copper penny is a little bit higher than calcite in the hardness scale. Even if they were equal to each other, they would be able to scratch each other. They still would be able to scratch each other. So that's why choice 2 is the correct answer. Because now take a look. Look, the mineral apatite will scratch topaz. That's not true. Because topaz is higher than apatite. So apatite's not gonna scratch topaz. And it says choice 4, a steel file has a hardness of about 7.5. When I look at steel file, it's between 6 and 7. So it has a hardness of 6.5, not 7.5. So the true answer is choice 2. All right. Now for number 8. When we take a look at number 8, let's take a look at number 8. Here we go. Let me zoom out a little bit. All right. So number 8 says, the table below shows some observed physical property of a mineral, gives the color, hardness, distinguishing characteristics, cleavage, and fracture. Based on these observations, the elements that make up this mineral's composition are what? So first we have to find out what mineral are they even talking about? All right. So where I want to start, we're going to start with these 3 physical characteristics. All right. Because that'll help us to break down what mineral that they're talking about a lot easier. Because if we start off with white, and you could start off with white, but there's a lot of minerals that have white, right? There's a lot of minerals that have white. So I kind of want to break it down to one of the more clearer characteristics. So we'll start with hardness. So it says, whatever this mineral is, it can be scratched by calcite. Well, what's the hardness of calcite? The hardness of calcite, it looks to be 3. So if calcite can scratch this mineral, the hardness has to be less than 3. All right, it has to be 3 or less. So I already know the hardness has to be 3 or less. 3 or less. All right. Next, it says distinguishing characteristics, right? That means that it feels greasy. So that means that when I look at distinguishing characteristics, it has to say greasy feel. All right. So let me start breaking some things down. So greasy feel, I see this one. What else do I see greasy feel? Right here, I see greasy feel. I don't see anything else that says greasy feel. Okay. And I know that it has to have a hardness of less than 3. So this one has a hardness of less than 3. This one has a hardness of less than 3. All right. And the common, I already see. Well, before we get to the common color, let's keep going because I already see what the answer is going to be. Then it says cleavage fracture definitely shows some definite flat surfaces. If you show definite flat surfaces, you have a cleavage breakage. So it has to have a cleavage check. So I see cleavage check, cleavage check. Now, finally, I see that the color is white. And between these two minerals, I see the color right here, white to green. So I know that it has to be talc, right? It has to be talc. So when I'm looking at talc, I'm going to look at some of these minerals, okay? And I'm going to see if it matches up. So Mg, Si, O, O, and H. So when I look, Mg, Si, O, O, H. When I scroll down, I'm going to circle what I just see, right? So with talc, I see Mg, Si, O, O, and H. So hydrogen, magnesium, oxygen, and silicon. And so when I take a look, hydrogen, silicon, hydrogen, magnesium, oxygen, choice 3 is the correct answer. Choice 3 is the correct answer. Let's keep going. Choice 3 is the correct answer for number 8. All right, number 9. All right, number 9 says the mineral shows. Oh, that's it. Share it out. Okay, there we go. The diagrams show below the results of one test for mineral identification, and it's showing that you're taking the powder from the mineral. As soon as I see you're taking the mineral powder, there is one test that I'm thinking about as soon as I see powder, and it is streak. You're testing streak. When you're looking for the minerals powder. When you're rubbering it all across a plate for the powder, you're testing for streak. So 9 is 3. Number 10. Number 10, it says, based on your answers to the following question due on the information below. It says, a student on a field trip in New York State collected a sample of metamorphic bedrock containing bands of coarse-grained crystals of plagioclase, feldspar, pyroxene, quartz, and mica. List 2 of the chemical elements found in plagioclase feldspar. So I'm looking at plagioclase feldspar. Page 16 tells me the elements, right? The elements that make up plagioclase feldspar. So I see plagioclase feldspar right here, and all I need to do is name 2. I'm just going to circle all the elements that I see, right? So I see Na. So I see Na, sodium, right? These are all of the elements here. I see Ca, calcium. I see Al, aluminum. I see Si, silicon. I see O, oxygen. So any 2 of these would be a correct answer. Aluminum, calcium, sodium, oxygen, or silicon. Any one of those would be correct for number 10. All right, let's keep moving for number 11. Silicate minerals contain the elements silicon and oxygen. Which list contains only silicate materials? All right, so let's see. Which list contain only silicate materials? So silicate minerals contain the elements silicon and oxygen. So I'm going to look for a mineral that has silicon and oxygen, right? What is the chemical symbol for silicon and oxygen? Silicon is Si, oxygen is O. So which of these minerals have Si and O? So I'm just going to go down the list and just circle them. All right. Which one has SI and O? Which one has SI and O? So let me zoom so that way I can see everybody. Give me a second? Okay. Yep. I see everybody else. All right. So SiO, SiO. Graphite, no. SiO, SiO, SiO. Okay. Talc, SiO. S-I and O. S-I. Remember, it has to be S-I, not just S. It has to be S-I and O. Muscovite mica, S-I and O. Biotype mica, S-I and O. S-I and O, S-I and O, S-I and O. Amphibole, S-I and O, I see. Pyroxene, X-I, S-I and O. What else? What else? Potassium feldspar, Si and O. Plagiocase feldspar, Si and O. Olivine, Si and O. Quartz, Si and O. And garnet, Si and O. And so now I'm basically just gonna match to see which four of these minerals cover the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So when I'm looking, graphite wasn't on the list, so I can cross that out. Graphite wasn't on the list, so I can cross out one. All right. Potassium feldspar, quartz, and amphibole. Let me see. Potassium feldspar, quartz, and amphibole. Yep. It's choice 2. It is choice 2. It matches all of the ones that have Si and O. All right, because it says silicate minerals contain the elements silicon and oxygen. All right, let's keep going. Number 12. So it says, basic answer to questions 12 through 14. Okay. Now, complete the table below to show the properties of the mineral diamond and graphite. All right. So diamond is actually not on here, but it says complete the table to show the properties of the minerals diamond and graphite. All right. So pure carbon comes in several forms. It includes the mineral graphite and diamond hardness of 10. So automatically, they tell us the diamond has a hardness of 10. So I'm just going to put 10. All right. Hardness of 10. Okay. After that, when I look at graphite, what's the color of graphite? You're just filling in the chart. So graphite has where is graphite? Here we go. Graphite has a color silver to gray. So if you want to say silver to gray, all right, that's fine. Luster. Graphite is located right here. So it has a metallic luster. So I would type metallic. That's a metallic luster. And the hardness, it says between 1 to 2. So you can say anything from 1 to 2. So I'm just going to type the properties of mineral. I'll just write 1 to 2. And boom, we're done with that. All right. Number 13. Number 13. Explain why graphite and diamond have different properties. All right. So graphite and diamond. Let's see. So when I'm reading, look, it says almost all diamonds are from igneous rocks. And graphite is formed through metamorphism of organic material rock close to the Earth's surface. So one of the reasonings you could have said. Diamonds are mined from igneous rocks that originates inside of the earth, right? A depth of 150 kilometers under immense pressure. And graphite is formed through metamorphism of organic material and rock close to Earth's surface. So one of the things you could have said is that diamond is formed deep in the earth, graphite is formed on the surface. You could have said that. Diamond is formed deeper in the earth, graphite is formed closer to the surface. You could have also said diamond comes from igneous rocks and graphite comes from metamorphism of organic material. You could have said any of those, that would be fine. Okay? All right. And number 14, it says identify 2 uses for the mineral graphite. When you look on page 416 of the reference table, all right, and we take a look where I see graphite, look where I see uses, and it's literally right here for graphite, right here. So you could have said it's used for pencil lead and lubricants. If you wrote pencil lead and lubricants, then that is correct. And that is the end of the question.